Okay, so let's look at the last exponent law that we're responsible for this year. Okay, and it's a negative exponent law. So this one also seems to students seem to struggle with because again, it doesn't quite make sense to you. Now, again, what I'm going to do is I'm going to actually use numbers so that you actually can see how it works. So for instance, I'm going to take the number a half. Now, 1/2 is the same as 0.5. You know that, right? And I'm also saying that if I go and take a calculator, and I'm going to bring up my calculator, and I actually also take the number 2 to the negative 1, what do you think my calculator is going to give me an answer for? Because it doesn't repeated multiplication and I've got a negative number, like how would that work? So if I go 2 to the power of negative 1, it tells me it's also 0.5. All right, so watch me again. So 2 to the power of negative 1 equals 0.5. And I also know 1 divided by 2 equals 0.5. So really what we found out then in this case, just like the other one in the sense, both of these equal 0.5. We can see that both of them equal 0.5. So that means this and this also must be equal to each other. So in fact, what you found is, therefore, 1/2 equals 2 to the negative 1. So the way it works with negative exponents then is we take the base, in this case it's a, and we reciprocate it. So we flip the base, so because this is right now over 1, so I flip it, so it becomes 1 over a. Now you just can't flip things and not do anything else. So it flips it, and the power, the exponent here, then changes to a positive. Now let's take a look at this question here. If I follow it, 2 to the negative 1 should then be, I should be able to flip the 2, so it'd be 1/2 to the positive power of 1. Okay, well, and guess what? It does work. Now, sometimes you'll see this exponent law the other way. What happens if I have a negative exponent on the bottom already? Okay, so what it means, again, I reciprocate the base. So it flips, if it's on the bottom and it's negative, it flips so that the base then is on the top and the power becomes positive. Okay, so I can do that with any one that I want. So I could even take the number 7, 1 over 7 to the negative 2. According to this, that would be 7 squared, which you know is 49. Hopefully you know that. So let's take the calculator and see if that's actually what it gives me. All right, so I'm going to bring it up again, clear what we have on there. So 1 divided by, now I'm going to put a bracket because I don't trust a calculator, 7 to the power of negative 2 equals, oh, it equals 49. So it does work. If you actually take any number and apply the law either way, it does work. Okay, so let's take a look now at some examples. Okay, so the first example that we're going to look at for actually all of them today says the word simplify. Now, what the word simplify means in this case is you're going to use exponent laws to simplify, but do not evaluate. So in other words, I don't want that when I'm finished here because I know what the answer here is going to be. It's going to end up being 3 to the negative 6. I don't want to know what that number is. I just want it to be simplified. So let's talk about this. I'm dividing. My bases are the same. According to the exponent laws, I'm supposed to be able to subtract those powers. So that's what I'm going to do. I've got 3 to the power of 3 minus 9. Now, even though I can do 3 minus 9 in my head, I'm still going to write it down because it just makes it a little bit easier for my brain. Now, 3 minus 9 is negative 6. So that's the same as 3 to the negative 6. Now I also have an exponent law that says when I have a negative exponent, I flip my base. So in this case, 3 is going to be flipped to 1/3, and I put it to the power of a positive exponent. Okay, and that is simplified. So simplified form means I don't want a negative power. I want my power to be positive. Okay, so that's where I stop. So I don't want to know exactly what that equals. It's actually quite a small fraction. Right, so let's do another example together. Now this time you'll notice both of these questions, my base is actually an x. Okay, so it's possible that you can have a base that's a variable, and there's nothing wrong with that. There's nothing that says you can't have that. So again, brackets, okay, around this, and what that means is this means multiplying. Okay, you should have seen that at least grade 7 and 8. All right, so I'm multiplying. My base is, in both cases, are x. So what do I do to the exponents? Well, I am supposed to add them. So that would be the same as x to the power of 2 plus 5. 2 plus 5 is 7. So my answer is x to the 7th. So my answer is simplified x to the 7th. Now this one is a power to a power to a power. Okay, so if you notice, it looks kind of crazy to your brain, but all it's doing is power to a power to a power. Well, what do you do with to a power to a power? Well, you're supposed to multiply. So all we're going to do is 3 times 2 times 5. Okay, that's all that one is. So 3 times 2 is 6, 6 times 5 is 30. And so there's my final answer. Now the next one, if I look at 2 and 3 to the power of 5. So what do I do in this case? 2 and 3 are not common bases. But what can I do with this exponent 5? Well, actually what I can do is I actually can bring it in to each one of them, and I could end up having 2 to the power of 5 over 3 to the power of 5. Right? And you're saying, well, that's kind of stupid. Why do that? Well, I'm going to tell you why. 2 to the 2 2 divided by 3 is decimal 66 repeating. And then that to the power of 5. So if I actually had to evaluate that, that would be 0.6 repeating to the power of 5, which would not be 3. Okay, it just wouldn't be that. Where if I have 2 to the power of 5, let's take our calculator. 2 to the power of 5 is going to be, I believe, 32. And 3 to the power of 5 is 81 times 3. So that's going to be 243, 243. Okay, so if you notice, that is much easier to work with. I didn't have to pull out my calculator, but try to do decimal 6 repeating to the power of 5. I don't know how I could do that in my head. I just wouldn't be able to. I would have to pull out my calculator to do it. So in this form, it's much more useful. So even though we use our calculator, we don't want to rely on it completely. All right, because depending on what kind of program you go into after you leave high school, whether it's work or whether it is even if you're going into sciences or math, sometimes they don't allow you to use a calculator the same way that we do. All right, so now what you're going to do tomorrow in class is you're going to work on these questions. You notice today's lesson was a little bit longer. Tomorrow's lesson won't be, but we're going to spend a few days on the exponent laws to try to make you feel a little bit more at ease at working with them. Okay, so I'll see you tomorrow in class.